Welcome back, students, to the lecture series of Operating System. Myself, Moushumi Shah, Assistant Professor of Computer Science and Engineering Department, Nadula Institute of Technology. Our today's topic of discussion is about deadlock. Okay, we first in a previous couple of lecture we discussed about what is deadlock. Like a deadlock is a state when two or more processes are waiting indefinitely for an event that can be caused only by one of the waiting processes. Okay, so we already saw that there are three principal methods for dealing with deadlock. Uh, One is we use some protocol to prevent or avoid deadlock and ensure that the system will never enter in a deadlock state. Okay, and we also allow the system to enter a deadlock state, then we detect it and then we recover. And another is ignore the problem altogether and pretend that the deadlock will never occur in the system. So the third solution is one used by most operating system, that is including the Unix and or Linux and Windows also. Okay, so a deadlock can occur only if the four necessary conditions hold simultaneously in the system. What are the four conditions? The conditions are mutual exclusion, hold and wait, no preemption, and circular wait. Okay, to prevent deadlock, so we can ensure that at least one of the necessary condition never holds. Okay, so by ensuring that the one of these four condition will never hold, we ensure that the deadlock will never happen in our system. The another method of avoiding deadlock, that is less straighten that the prevention algorithm require in the operating system. Having a We need a prior information on how much process will utilize the system resource. Okay, so for example, okay, the considering the snapshot. Okay, there are a allocation chart is given, a maximum chart is given, and the available resources in our system, this value is already given. We use Banker's algorithm, for example, that require a prior information about the maximum number of each process. Suppose in our system how many processes are there. Okay, we have a prior information, for this example there are 5 processes are there. There are 4 different type of resources: A type resource, B type resource, C type, and D type resource. Okay, each and every resource have multiple instance. Okay, and so now we can solve this example. uh, okay, in our previous lecture also we solve Banker's algo. So today again we solve another problem. Okay, so after for this, answer the following questions. Okay, using Banker's algo. What are the questions? First question is, what is the content of need matrix? So for solving Banker's algo, okay, if it is the question is given or not, we have to calculate the need matrix. Without the help of need matrix, we can't proceed further. Okay, to solve the problem, we must find what are the need matrix. And second one is, after solving the problem, we have to check if the system is safe or not, because we know there is two sequence in a system, maybe a safe or unsafe. Okay, so deadlock occur means the system is in unsafe state. Okay, but if all the force condition is not satisfied, if anyone can we can prevent, so we can say this is unsafe state but not deadlock. And if no condition is satisfied, then we can say the system is in safe state, there is no chance. And the third question is, if a request from P1 Okay, there are five processes for this particular example: P0, P1, P2, P3, P4. And if a request from P1 arrives uh, for uh, 0420, that means that means uh, uh, the A type resource need is 0. The P1 needs A type resource 0. It needs additional B type resource 1. Okay, okay. 4. An additional request for P1 request additional request for C is 2. So A type resource it needs nothing. B type resource it needs 4. Okay, 4 extra B. Okay, 2 instance of C and 0 instance of D if P1. So can the request is grant immediately or not? So we have to solve this also in this particular example. So now first we have to calculate need matrix. The formula of calculating need matrix is need equals to max minus allocation. Here the max is in this problem, we can see the max is the maximum demand of each and every process. Like for P0 the maximum demand is it needs 0 instance of A type resource, 0 instance of B type resource, 1 instance of C type resource, and 2 instance of D type resource. Okay, same P1 the maximum demand is P1 needs 1 instance of A type resource, 7 instance of B type resource, 5 instance of C type resource, and 0 instance of D type resource. Similarly for P2, P2 needs its maximum demand is it needs 2 instance of A type resource, 3 instance of B type resource, 5 instance of C, and 6 instance of D. Similarly for P3, 0 it needs 0 instance of A type resource, 6 instance of B type resource, 5 instance of C type resource, and 2 instance of D type resource. And lastly for P4 it needs 0 instance of A, 6 instance of B, 5 instance of C, and 6 instance of D. So these are the maximum demand. Maximum demand means if P0 got all the resources, then he can start his execution. If P1 got all the resources, okay, all the different type of resources, P2 if their demand is fulfilled, then they can start their execution. And here allocation is when the process created, that time from our system, the system having some resources, they allocated some resources to the particular process. Like at the time of creation, P0 got 1 instance of C type resource and 2 instance of D type resource. Okay, when P1 is created, it got 1 instance of A type resource, okay, only. And for P2 it got 1 instance of A type resource, it hold a 3 instance of B type, 5 instance of C type, and 4 instance of D type. Similarly for P3, at the time of creation, it from the system resource it got 0 instance of A type resource, 6 instance of B type resource, 3 instance of C type resource, and 2 instance of D type resource. And lastly for P4, it holds 0 instance of A, 0 instance of B type resource, 1 instance of C type, and 4 instance of D resource. So after providing these resources to the several processes, now in our system this is the available chart is a vector where now currently in system only 1 instance of A type resource is available, 5 instance of B type resource is available, uh, 2 instance of C type resources available, and 0 instance of D type resource available. Okay, from this available resources we have to perform Banker's algo. Okay, so need equals to max minus allocation. Here I write the chart. Okay, and so we can do matrix subtraction. Okay, so from 0 0 1 2 we have to deduct 0 0 1 2. So the maximum need of P0 is 0 0 0 0. Okay, for P1 maximum demand is 1750 and it got 1 only. So its need matrix is 0 for instance 7 5 0. Okay, now for P2 2 to 1, that is 1, from 3 to 3 0, 5 minus 5 0, and 6 minus 4 2. So its need matrix is 1 comma 0 comma 0 comma 2. Now for P3 that is 0, from 6 minus 6 0, from 5 minus 3 2, and 0. Okay, 2 minus 2 0. And for the last process P4, okay, 0 minus 0, 6 minus 0, that is 6, 5 minus 1, that is 4, and 4 minus 6 minus 4, that is 2. So this is our need matrix. Okay, we got the need matrix. Now we have to perform bank by with the help of safety algo and resource allocation algo. Okay, we have to perform our bankers algo. So we already know the need matrix and we have our available matrix also, so we can apply the bankers algo. Okay, so we have to search the need matrix for P0 to P4, so which is less than equal to available. So now first we check P0's need. P0's need is 0 0 0 0, so that is less than equals to available. This statement is true. So after completion of P0, so P0 starts its execution. So P0 is executing. Okay, it is in running state. After completion, P0 terminated, and the resource which P0 is allocation, when P0 holds at the beginning, that is 0 0 1 2. Okay, that will be uh, uh, come to the available resources. Okay, so here uh, uh, after completion of P0, our available equals to available plus allocation, that is our current available plus allocation of P0. Okay, so the value is, our available is 1520 and allocation of P0 is 0012. So currently our new available is 1532. Okay, now we have to check uh, P1's need. Now P1's we have to check is the need is less than equals to available. So P1's need is 0750 and our available is 1520. So we can fulfill C's instance and D, but we can't, we can't provide B and C type resource, okay, to P1 because our available is less than the need. So we can't allocate our resources to P1. Okay, so now we check for P2. P2's need is A type resource 1 and D type resource 2, as it doesn't need any B and C type of instance. So we can its need is less than equals to available because our available is currently 1532. Okay, our current available is 1532. So we can easily grant P2's request. So after completion of P2, now this 1354, this value which P2 holds at the beginning, these resources are coming back to the our available. Okay, it's coming back to the system when P2 terminates. Okay, it whatever the resources we provided, it will back, and additionally it will back this 1354 resource also. So now our available equals to our current available plus allocation of P2, that is 1532 plus 1354. So we got 2886. Okay, now we have to check for P3. Our P3's need is 0020. Okay, in need matrix it is given 0020. So we can easily provide grant P3's request. So we from our available we give 2 instance of C type resource to P3. Now P3 execute and terminates. So after termination, P3 back the 2 instance of C type resource. Okay, to the, so our system is whatever the value it will give, it will come back to the system. Additionally, it back 0632 also. This instance also it is. So now available equals to our current available plus allocation of P3. This value is 2886 plus 0632. Okay, so the value is 2 plus 8 plus 6 14, 8 plus 3 11, 6 plus 2 8. So our current available is 2486. We already execute P0, P2, P3. 3 processes are terminates. So we can one by one we can execute some processes. Okay, because this is a deadlock state, but the banker's algo will help to give the resources to the process, then the process can execute and the system is avoid the deadlock. Now P4's need is less than equals to available. Yes, its need is 0642 and we have more than 0642 resources for more than 6 B type resource 6. Okay, we our available resources are more than 4 for C type instance. For D its need 2 and we have 8. So we can easily provide our resources to P4. So after completion of P4, our available equals to available plus allocation. So that is 2 14 11 8 plus 0014. 0014 is this value which P4 hold initially. Okay, at the time after creating time when P4, then our system provides these resources to P4. So it will release this resource, so it will come back to the system again. Okay, now we already execute 4 process and P1 we can't give resources to P1, but now we can check again. Okay, now after checking P1's need is less than equals to available or not. Yes, we have enough resources to give P1. So after completion of P1, our available equals to 2420 plus it hold 1100, that is come back to our system also. So our current resources 3432. Now we can check that we can easily, okay, if we execute our system not in ready queue order, if we execute in this order, we can easily avoid deadlock. Okay, what is the sequence? And you can check also this, we in our system we initially we allocate 1 2 two instance of A, okay, to P1 and P2, and in our system one instance is free available. So we have maximum 3 instance of A, and at the end we can check the 3 instance of A again. Okay, B instance is provided to P2 and P3. Here 6 and 3, 9 instances are hold by P2 and P3, and we have 5 free. So 9 plus 5, so we have maximum 14 instance of B type of instance, okay, in our system. And here after completion of 5 instance it shows 14. Again check, okay, the C type of resource. at the beginning 1 instance for P0, 5 instance for P2, 3 instance for P3 and 1 instance for P4. That means 5 plus 3, 8, 9, 10. 10 instances allocated to several processes and 2 is free. So 10 plus 2. So here we can check, okay, our total is available resource of C type is 12. Again for D we can check our system resources 4 plus 2 plus 4 2. These are allocating at the okay, from our system we can allocate at the beginning and we have available, nothing is available. So 4 plus 4 8 9 10 12. So this 12 instance we have. So we can backtrack it. Okay, and for the safe this by using Panker's algo we provide a safe sequence. At the safe sequences, first we have to execute P0, then P2, then P3, then P4, then P1. If we execute our processes in this manner, so we can easily satisfy the request and move to safety. Okay, and for now move to question 3. In question 3, it is if a additional request from P1, what is the additional request? 0 4 0 4 2 0. Okay, 0 4 2 0. So if our system having more than, it needs A type resource and D type resource, it don't want, it only request for B and C type resource. Okay, so in our system initially our available is 1 5 2 0. So if we provide this 4 2, so from our available chart we can give. Okay, so if at the extra on additional requirement of 043 is granted, so we have to check it is granted or not. So first we minus from 1520 we minus 420. So we have one instance of A, one instance of B, 0 instance of 2 minus 2, 0 instance of C and 0 instance of D. So now our current available is 1100. Okay, and P1 initially in the previous problem P1 hold 1000. So now P1 holds 1420. Okay, so our available is changed if we grant, and our allocation is also changed. Okay, now we have to check, we have to calculate the need matrix and check from this snapshot, is the system is moved to the safe state or not. Okay, if the system is moved to the safe state, then we can say the request is granted. Okay, if our solution is not providing a safe state, then we can not grant. Okay, so here for question 3, the need matrix is change for A0, that is same. Okay, max minus allocation. So 0012 minus 0012, that is 0000. Now from 1750, in previous problem we minus 1000, here we have to minus 1420. So need is 330330. For P2's need is 2356 minus 1354, that is 1002. For P3 the max is 0652 and the allocation is 06, so the need is 0020. And for last process P4, the max is 0656 and the allocation is 0014, so the need is 0642. Okay, now again we have to check our available is 1100. Now first P0 executes. Now we have to check the sequence, we got the sequence or not. So after executing P0, okay, so after executing P0, our current available is 1 1 1 2, because we know available equals to available plus allocation. So P0 is executing after terminating. It release these resources, this 1 and 2 resources of C type and D type. So it will come back to our system. So our system resources now is 1 1 1 2. Now we check, we can give these resources to P1. No, we can't give these resources to P1, because if we give these resources to P1, that time also P1 is in waiting state, because its need is not fulfilled yet. So giving P1 is useless, so we can't give our resources to P1. Now we can check for P2. The P2's need is 1002. 1002. So we can easily give the resources to P2. Okay. So it take from our available, it take 1 and 2. So after completion, it back this one again and this 2 again. So this is same. Additionally, okay, so P2. After P2 terminates, this is come back to our system, these resources 1354. So our current available is, after execution of P2, our current available is 2 1 plus 3 4 5 plus 1 6 and 4 plus 2 6. Okay, so A type resource available is 2, B type 4, C type instance 6 and D type instance also 6. Okay, our current available. Now P3's need is 0020. So we can easily give our resources to P3 after completion. Okay, P3 finish. So we give the resources to P0, then P2, then P3. After giving to P3, P3 release this resources, and that is come back to our system. So currently our system resources is 2 type of A type of instance 2, B type 6 plus 4 10, comma 10, C type of resource 9, because 6 plus 3 9, and D type of resource 8. Okay, 2 10 9 8. After giving resources, P4's need is 0642. So we can easily grant P4's request, because P4 need is, okay. So after completion of P4, now our system resources, available resources 2 10 2, then 10, 9 plus 1 10, and D type of resource 8 plus 4 12. Okay, so our current available is 2 10 10 12, and need of P1 is 3300. Okay, 0330. So we can easily provide, okay, we can easily provide. So now we can give our resources to P1, and after this execution of P1, this 1420 is released. So we got 3, our available is 3, B type of resource 10 plus 4 14, C type of resource 10 plus 2 12, D type resource 12. Okay. So our system, okay, in the previous program also we saw that our system resources is 3, 14, 12, 12. Here again, the, the available resource after completing the 5 process, the available resource is 314. So the save sequence, this is the save sequence. We can uh, grant the P1 after P2 also. Okay, if we the execute P0, then P2, then we got 2466, and P1's need is 0330. So we can, after here we can give the request to P1 also, P1. Okay, then P3 and P4. So if in question, if they want multiple save sequence, so we can give another solution also. Okay, if we run our processes in this sequence, after that we got the save sequence also. Okay, so the answer for third is yes, we can grant the request for P1. Okay, so we saw that how we solve a particular problem in Banker's algo using Banker's algo. Okay, and after the deadlock avoidance algo, we also check how to detect deadlock. Okay, so for detecting deadlock, there are two mechanisms. One for single instance, we use wait for graph from resource allocation graph also, and another is uh, Banker's algo. Okay, for multiple instance, this algo is similar to Banker's algo, and finally, we prevent deadlock. Okay, we recover deadlock by using abort all the processes or aborting the processes one by one. Okay, so this is all for deadlock. Okay, I hope you understand. If you have any query, okay, you can contact me. My mail ID is given, and this is some reference books. Okay, thank